Okay, let's get started. What we've been doing recently is we've been looking at engineering. We've answered lots of questions. We've done lots of theory, right? We've done a lot where I've made you think. So what we're going to do is we're going to put it into different practice, okay? We're going to take a different angle. We're going to go this way, okay? So far we've been going straight. Now we're going to go a bit like this. Okay? We're going to open up like a flower. So what we're going to do is I'm going to give you something practical to do at home, and I'm going to give you a little bit of theory as well. The theory is quite small, but the practical should be a bit of fun. And it's something you've probably all done before, which could be more interesting too, okay? So let me share my screen with you. When we've been looking at engineering, we've looked at the idea of engineers using scientific principles in order to design their machines. We've asked you some questions about what are some scientific principles and what do they do, etc., 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 etc. But what we're going to do today is we're going to kind of, as I said, go off on a little bit of a branch and start having a look at scientists. Now, the practical thing we're going to do today is very, very simple, something for you all to do at home. First thing I'm going to ask you to do today when you're at home and you have all those things to do at home is I'm going to ask you to build a helicopter. Very, very simple, nice and easy, not that hard. So here's a quick video for you to watch about helicopters. So who has some questions about building this? Hun?
I don't have enough like materials because I don't have the pin and something, but I don't really have a pin.
The paperclip? Okay. So what can Hun do instead of using a paperclip? Billy, your hands up.
She could use tape.
Thank you very much, Billy. See? Look. Billy, the genius. Good stuff. Anybody else have any questions about this? Pumpkin, have you done something like that before? Cool.
Don't have a paper clip and tape.
Right, let's talk about that, okay? So, on the next page, okay? So, I've got some questions. Let's keep thinking about things in the engineering perspective, okay? So, what are you going to do first, okay? So, you have this idea, you know roughly how to do it. What's the first thing you're going to do before you start building? Hun, what's the first thing you're going to do?
I'm gonna take the materials and watch again the video.
There we go. That's the first thing I would do, is I'd watch the video again. Like, I've never done this before. I've got no idea how to do it. Remember we spoke about research, okay? So, you having this idea. Problem is, how do I make some paper fly? I have an idea about a solution, but I'm going to do some research, so I'm going to watch the video again. Okay, so once I watch the video again, I know exactly what I'm going to do. Then you're going to get all the materials together. Now, in the situation where you can't get all the materials, what can you do? So let's think about what materials do we need? We need paper, we need scissors, and we need something to hold the top together. So what can we do? What are some things that hold the top or that can hold paper together? Rosie?
Tape.
Tape. What else?
Paper clip.
Yeah, a paper clip, right? Like any of these things are going to work, okay? The reason for the paper clip is two things, okay? So one, the paper clip holds the paper together. But two, it adds a bit of weight, okay? The reason you need a bit of weight is that when you're pushing down on the paper, it's going to help it spin faster, okay? You don't need it. It's not 100% necessary. When you fold paper and you fold it enough, it's going to stick together anyway. So you don't really, it's not 100% necessary. Now, I have a question. Does the size matter here? Winter, what do you think? Does the size of the paper copter matter?
No, I don't think that it is matter.
When you're building this at home, first thing I would do is watch that video. Then I would get your materials together. Just figure out ways that you can put it together. It doesn't have to be exactly like that, but follow the same idea, okay? If you are finding that it's not working, what are you going to do? You're going to test it. You're going to do some research, and you're going to try to improve it, okay? Like as we would as engineers. So what are the criteria and constraints of building something like this? Let's start with the criteria. Pumpkin?
It's made by paper.
Yeah, it's made by paper. It's a paper copter. It has to be made by paper. Perfect. Yeah, really good example. Good job, Pumpkin. What else? Cherry?
It can fly.
Yeah, that's two simple ones, right? One, it's a paper helicopter. What do helicopters do? Helicopters fly. What's it made of? Paper. Paper helicopter. It needs to be made of paper, and it needs to be able to fly. Good job. Super easy, right? What about constraints? Han, what do you think a constraint or limitation of the paper copter is?
You don't have enough material.
Okay, you might have not have enough materials. Okay, cool. What else? What do you think a limitation of it would be? Joey?
The constraint is that the helicopter does not spin.
Yeah, it might not spin, okay? So it might not spin, okay? That's a fair point. Okay, so imagine we build it. Imagine it doesn't spin. What are you going to do? Trixie, what are you going to do if the helicopter you build does not spin?
I will improve it.
How? what way will you improve it? Okay, so these are all things you're going to learn as you're going along, okay? So when you are at home and when you're building this, I want you to keep in mind the criteria. It's made of paper, has to fly. If it doesn't work, if there's things that go wrong, try again. But write down what you did differently. Tell me the way you approached doing something in a different manner, okay? Think about it from the engineer's point of view. What's an engineer going to do? How's an engineer going to approach it? Okay, good job. So that's what I'm going to want you to do when you are at home today, okay? If you can make a video, perfect, cool. So we are going to look at this from a different angle. So we're going to talk about scientists. So what or who are scientists? Why are they so important? Can you tell me some types of scientists? Billy, what's a scientist do?
A scientist learn more about our planet.
Yeah, so, yeah, okay, yeah, in a nutshell. So I'm going to talk about that a little bit more. Han, what do you think a scientist does?
The scientists improve the things that the engineers do and study and learn more and try to make it better.
Okay, so I'm going to take what you said there and what Billy said as well. So a scientist studies and learns, okay? A scientist's job isn't necessarily to improve on what an engineer does. What you're probably going to get is another engineer improving on what another engineer does. Remember, we talked about research. Remember, we talked about you looking to see if someone had done something to improve it previously. That's what an engineer will do. An engineer will look at what an engineer has done and then try to fix it. But a scientist's job is to study about the things, okay? To study scientific principles. As Billy said, to learn about our planet. But there's lots of different types of scientists. Thailand B, can you name a scientist for me? Han?
Thomas Edison.
Thomas Edison. Okay, Thomas Edison was a scientist and an engineer. Oh, Billy.
Isaac Newton.
Isaac Newton, yeah, okay. Isaac Newton was definitely a scientist. Winter.
Albert Einstein.
Einstein. Pro, can you tell me the name of a famous scientist?
Stephen Hawking.
Stephen Hawking, yeah, good job. Stephen Hawking's a really good example. Okay, good job. Okay, so there's lots of scientists, right? And they've all come from different times in history. They've all come from different places. Now, here's a good one. What type of scientist is Bill Nye? Billy?
I think he's a biologist.
He's a biologist? Okay. Anything else? He looks at biology. He looks at some other stuff as well. I'll be honest with you. I don't know what type of scientist Bill Nye is. Because Bill Nye is he just looks at everything, okay? Right? Remember all the videos we watched? Bill Nye just looks at everything. He doesn't just focus on one part of science, but he looks at all science. He looks at natural science, physical science, earth sciences. I'm going to explain those to you now to give you an understanding about what they are, okay? So let's go back to this. So some of your favorite scientists, there's three of mine: Isaac Newton, Nikola Tesla, and Isaac Newton. They're three of my favorite scientists, 100%. Who can tell me their favorite scientist and why? Why is their favorite scientist? Billy, tell me your favorite scientist and why.
My favorite scientist, Aristotle.
Aristotle. Why Aristotle?
Because he studied nature.
Okay, cool. Good job. Hun?
My favorite scientist is Curie.
Madame Curie? Cool. Why? Why Madame Curie?
Because she's the first woman who got the Nobel Prize, and then she's the first woman learn in the university.
Yeah.
And she's
Good
also
job.
the first woman being scientist on the world.
Yeah. She wasn't the first female scientist. She's the first recognized one. Okay. She her work she did on radiation was like outstanding. Okay. What I'm gonna want you all to do is I want you all to get a favorite scientist. Definitely. Because they're everywhere. Scientists are doing everything. It can be about sound, it can be about light, it can be whatever you want. Doesn't matter, okay? The reason I bring that up is because there's many, many, many different types of science. You've got earth science, it's about rocks, weather, and the planet. Physical science, matter and energy. You can tell me, what is matter? Billy, tell me.
Matter is everything.
Matter is everything, yes, okay. Okay, yes, fine. You're also scientific in your explanation. Matter is anything that takes up space and has mass, okay? So it takes up space and has mass. Anything that has mass and volume is matter. Then you've also got life sciences, living things like plants, animals, and their environment. This one is probably the most interesting one because, you know, animals are interesting. It also looks at people, why people do things. So I was to ask you, what does a biologist study? A biologist is someone that studies living things, living entities, living organisms, right? Animals, plants, people, all these types of things are what a biologist will study. You have marine biologists, you have wildlife biologists, you have fish biologists, you've got people biologists, you've got all these types of things, okay? They all fall under that kind of biologist bracket and understanding. So what kind of questions do you think a biologist asks when it comes to studying animals? So to help you, what a biologist will do, a biologist will look at what an animal does. Remember we spoke about patterns. A biologist will take a look at why an animal is doing something, what the reason that is, and then we'll then try to figure it out. If you take Darwin as an example, okay, what Darwin did, Darwin went to the Galapagos Islands, and when he was there, he looked at all of these animal traits and why they looked the way they did, and why all of these animals in the Galapagos looked completely different to everyone else, or different animals around the globe. So what he did, he started asking questions. He said, why? Why is it like this? Why does it do this? So the job of a biologist is to look at why these things happen. If you were to think about what an engineer does, an engineer says, okay, it does this. But because of the scientists, we're able to know exactly where it came from. So remember we said an engineer uses scientific principles. The scientific principles have to come from a scientist first. The scientist finds out why, an engineer can then use them. So imagine you were a biologist, okay? So a biologist's job is to find out the reason for things. So what I want you to do for your homework is build the helicopter. It's only going to take you a minute, and it's a bit of fun for you to do at home. But I want you to imagine that you are a biologist and you're going to study your favorite animal. I want you to do research into the behavior of the animal and then write some questions from the biologist point of view. So, for example, my favorite animal is a shark. A shark will swim away from somewhere when it can smell another dead shark. The question I would ask as a biologist is, how does a shark know what that smell is? Okay, and this is then something I would want to figure out. The reason I want to figure out is, hold on, if a shark swims away from the smell of another dead shark, how could an engineer use that? I know, people that are surfing can spray dead shark repellent or shark smell onto their surfboard and the shark won't attack them. There's a good way to get sharks to not attack you, right? Another one is, sharks also need to keep swimming. They can't stop. So how do sharks sleep if they have to keep swimming? What can I learn about this? So this is what I want you to do. Choose your favorite animal, think about something that animal does, and then write a question about that behavior. Thank you. Bye. Bye bye. Have a good day. See you later.